Hi everyone. Either welcome or welcome back. So a couple of things before we begin. One, thank you for filling out, to those of you who filled out the Qualtrics survey. I'm still compiling the results or the responses. The second thing is, so hopefully so what we want to do now is, again, we'll be using the CBRG package to go through today's material. And as I mentioned last time, before every class, either during class or before class actually starts, or the meetup starts, you can reinstall it. And to do that, you run this line. So if you've already done it, great. If you haven't, spend like a minute running this. There's one slight change, and I'll update the README to reflect this. Instead of using the DevTools package, we're using the remotes package. And this is an arcane point, not really worth mentioning, but with the DevTools package, you can encounter Ina encountered an error. But the remotes package, which is sort of like taking over this aspect of the DevTools package, is the more robust one. So we'll go ahead and use this. I'm just going to run this line of code. So it's reinstalling the package for me. And if you want, it's probably not necessary. Never a good sign. If you want to, if you want to run watch the presentation on your own machine, you can use the launch slides function. All right, there seems to be some kind of error. We'll just try to power through that. A couple of other changes. So last time we used these functions called launch class and launch homework to launch the respective in-class and quote-unquote homework material. We've changed the names of those functions to project and exercise. So project means what we're doing in class. So it's launch project, and then you just put in the number of the meetup we're in. So we're meetup 2, you would just do 2, and it would launch the project. And the same thing for exercise. So let's just go ahead and go through the little presentation itself. So today, yeah.
Can you show the remotes installed?
Sure. I'm just going to delete this. It's this one here.
What if it says unknown package from GitHub?
Then try DevTools. Are you sure that you're typing everything out correctly?
Yeah, that's right.
Okay.
DevTools will work the same.
So that's the thing. DevTools should work the same, but for some people are encountering an error with DevTools, so it's a little less. This one's more robust. I should also say that if you notice, I'm doing all of this within a project that I set up specifically for this meetup, and I know I'm in a project because of this here. So it's a CBRG meetups, and this is an enclosed environment where I can run all my code. We'll get back to that in a second. So today we're going to go through data visualization in R, and we'll cover a couple of a few base R functions, and then quickly move on to the much more powerful ggplot function. So yeah, we're going to cover base R way, and then as you can tell, I'm a lot more excited about the ggplot way. The data set we'll be using for, in the slides at least, this Golub data set, which we brought up last week. And so this is a pretty big data set of gene expression data for 2 different cancer types. So you can see this, this section of the data frame looks like this. We have gene names, and then the columns that correspond to different patients. And these are all, I believe, log2 gene expression values. So let's just cover some simple plots in R using base R functions. So if you wanted to do plot a histogram, there's a built-in function called hist. And this $ operator, or this $, I guess, function, is the base R way of extracting a given variable from a given data frame. Don't think we mentioned this last week, but this is quite a common thing to do. So this line of code will plot a histogram for the mean expression values for the ALL subjects. And that's one of the columns, numeric columns in our data frame. And the output you see here is a pretty clean looking histogram. You can see it has a slight right skew. So this is a quick way of getting a nice looking histogram. It's not much more to say. Similarly, if you wanted to make a box plot, there's a base out function called box plot, and it's kind of this. It works the same way as hist. The input is exactly the same. If you wanted to make a box plot for this mean ALL variable, you just replace hist with box plot, and we see we get this nice looking box plot. Okay, so now we can move back into our studio and try to accomplish the first challenge of the day. So we had a box plot for one variable. How would we get a box plot for box plots for all the individual variables? And so it's kind of unclear on this what variables we're selecting. But if we go back into our studio and launch our in-class material. So if we just do, if you've installed the CBRG package, you load it using this library command, and then you can use the launch underscore. Remember, we're calling it projects. Just use that error. I'm going to try something. I'm just removing this package because clearly there's a problem and I'm reinstalling it. Hopefully that should get rid of the problem. All right, so finally we go type in launch project, not fixed it. So this is something that hopefully it can fix after the meetup. If we launch project 2, because that's today's class, we get this, our markdown document. One thing I want to mention, which again, I didn't mention last week, is let's say you annotate this for yourself and you want to save the annotated version. So for example, there's this author here, it says your name, I want to put in my name. If you just hit save, you'll see nothing appears in your project folder. That's because what's happening is it's saving this, unfortunately, in the directory where this package has been installed, which is kind of useless for us. So instead of hitting save, unfortunately, you'll have to do save as, navigate to your project directory, and then hit save. And then you can see that it appears here. So sorry, there's a couple of extra steps if you want to keep track of this. Because unfortunately what happens is, so if you were to save it like this and you never update your package, each time you use the function launch underscore project 2, you will see your annotations. But the day you reinstall the package, those annotations will disappear. So if this is important to you, which I imagine it is, you'll want to save this in your projects directory. All right, so this is our markdown document. The first thing we want to do is we want to install the relevant, load the relevant packages and import the relevant data. So you'll see here, we have another package called Tidy Biology. And this is a package that Matt has made for his Tidy Biology course and meetups. And it also contains lots of useful functions, but importantly for us, it also contains important data sets that we'll be using both maybe for today, for this session, but certainly for the take-home homework part. So I'm assuming that, well, whether or not you have it installed, you can just go ahead and run all of this and it'll just reinstall. And yeah, just keep an eye on your console. So sometimes this is something worth knowing. If you just have this screen open and you just see this green bar, it looks like nothing's happening or it's stuck. That's because it wants you to do something. So if typically if I want you to do something, you should go to the console. And it's asking if you want to update some of these packages. I'm just going to go ahead and say, sure, yeah, update all of them. So again, if we encounter any errors, like this is the most error-prone part because maybe your machine might not like this. Hopefully, there are no issues, but let's go ahead and do this anyway. And while this is running, you can see there's this line here where I'm importing the golib data. And this is from a URL, so it exists somewhere on the internet. And we're going to save it as an object called golib subject. And so we can see that in our global environment here. We see it as an object. Additionally, I ran this function called data, and proteins is the name of a data set within the tidy biology package. And so if you do this data proteins after you've loaded tidy biology, you see that it comes up here. And if you want to actually see this as a data frame, just double click it. It's in our global environment. And this is what the proteins data frame looks like. And we'll be making use of those in today's class. All right, so that was a lot of talk for setting up. Okay, so hopefully you can see this clearly. So these are the instructions. So just going back to this, it's kind of small. Let's try to recreate this using the boxplot function. So I've written here, make box plots for all the columns in the data frame golib subjects except for these three: gene name, mean ALL, and mean AML. And there are some hints. So step one, which you can put here, is, well, we need an environment to run our code. So step one is to insert an R code chunk. Does everyone remember how to do that? You can either go up here and find the relevant code chunk and then click on it, or you can do on a Mac Command Option I, and then it just opens one. So if we go through this line by line, which function would you use to work out how many columns your data frame has? Anyone? Dim. We do dim golib subject. It tells us that we have 3,051 rows and 41 columns. All right. The next one is using this information, select the relevant columns. So what that means is, in fact, if you just click on golib subjects, you can see what the columns are. And the ones that are of interest to all of these, ALL1, ALL2, and so on. So we want to exclude gene name, which is column 1. And if we go all the way to the end, we want to exclude these two mean columns, which are columns, you can just hover over here, and you see column 40 and column 41. So that's kind of the clue. To make this box plot, we need to make an intermediate data frame that doesn't contain these three columns. And what I haven't said previously, but that's line 3, the useful thing about this box plot function is it can take in a single variable and make you a box plot, or it can take in an entire data frame as an input. So if we just ran this, for example, box plot, golib, subject, we would get multiple box plots. The only problem here is box plot subjects also contains gene name, which is a character variable. So actually, I'm curious, if we just ran this, see, it says that it's not going to work because we have a non-numeric argument, which it doesn't take. So just as a clue, if we want to select using the, in this case where I'm going to use the base R way, you could use the tidyverse select function if you wanted. What you could, one quick option, especially if you don't want to create an actual intermediate data frame, is to use these square brackets. And if you recall, if you do space, comma, that means you want all the rows, which is what we want. And then we can exclude, or rather, I take that back, include the columns we want. we can do it like this. Oops. Use this combine function, and then we just say we want, let's see, we want everything from the second column up to the 39th column. So if we do this colon 39, run this, we get this nice looking box plot. And this is a very common thing that people do to make sure that there are no batch effects if their data are roughly, what the distribution of their data is. And the great thing about the box plot function, so ggplot in general is superior to baseR, but if you just using the data set in its current form, if you wanted to make a similar box plot, it would be a little bit more involved. But the box plot function, the built-in one, handles the data as is really well. So this is a really common first step you will see with any kind of omics or big data. So that's pretty much it for the baseR part of this meetup. So we're going to move on to ggplot. This is an example of the power of ggplot and what it can do for you. So this is specifically this is a package called bbplot that is built on top of ggplot, and it's an internal package made by the people at BBC, and they've actually open sourced this. So there is a bbplot package that you could install, and if you go through their instructions, you can very easily convert your plots into plots that look like this. This is the famous Gapminder data set. So this is an animated bubble chart. There's a highly watched TED talk that describes these data and this kind of data visualization. To do it in ggplot is also really straightforward, including the animation bit. Like the quote unquote hard work is to actually make a static plot. And then to convert it to an animated plot takes like 1 or 2 lines of code using the ggAnimate package. More important than the animation, which I'm not sure how many people are really interested in, is this. This is an example of a plot that tells you a lot in a really nice way. Like it looks like it's conveying information across 5 dimensions. So we have our x-axis and y-axis values, GDP and life expectancy, but also we have information on the population size that we can see based on the areas of these circles, and also the larger regions. So each individual dot corresponds to a country, but the color tells us which larger region these countries belong to. And also there's this temporal component. We can see the time axis. So surprisingly simple plot, or a simple plot that conveys a surprisingly large amount of information. All right, so that's ggplot. So why ggplot? It's easy to use. Importantly, it works really well with dplyr, and it's powerful. So dplyr is a package we briefly touched on last week, and is one that we'll be revisiting routinely. So we made a histogram using the hist function, and this is a histogram using ggplot. So we have ggplot. Every ggplot, all ggplot code typically begins with this ggplot function itself, and it takes in a named data frame. So in this case, it's Golub subjects, and ggplot has this layering logic. So you build a plot. It's kind of like a painting. You have an empty canvas, then you add some paint, you add some more paint, and so on. So you kind of layer it. It's the same logic you apply to making a plot in ggplot. And the way you add these layers is by using this plus sign. So this is slightly different from dplyr, where we use the pipe. In ggplot, we use the plus, which kind of makes sense. That's how you add layers. And we have these functions. We have different functions, so-called geom functions, for different plots. So since we're making a histogram, we have geom_histogram. And then in that, we give it the variable we want to use to make our histogram, which is mean ALL. Now, importantly, we put this variable with another function. This is the only additional, maybe slightly confusing bit at first, this aesthetic function. And what aesthetic does is it it forms a connection between the data in your data frame and the visual output. So anytime you are, as they say, mapping data from your data frame to some aspect of your plot, you have to use this AES function. And that's what the output looks like. Not as nice as the BaseR hist function, but this can easily be improved. So just quickly, I mentioned just kind of briefly the syntax of ggplot code. This is sort of what it looks like. This is from the Art for Data Science book. And so here we put our data frame in the ggplot function, and we have a particular geom function depending on what kind of plot we want to make. And then we have this mapping. Now, there are these parameters, data equals and mapping equals. You can just drop them if you want for brevity's sake, or you can keep it there to remind yourself of what these parameters are. So this is kind of the generic syntax, and this is an example for the histogram. The great thing about ggplot is once you have your code in there and you decide that, oh, I want a different plot, it's really easy to, you just have to make minimal changes to your code. So let's say the histogram was a little chunky and you want a smoother output. There's a function called geom_density, and you get a density plot. And this might be an improvement. So these two just highlight the slight differences. And then, so we have a histogram, we have a density plot. If you wanted to make a scatter plot, it's not geom_scatter, it's geom_point. And the only other thing we change is, since it's a scatter plot and we have two variables, we put in the second variable we want in our scatter plot, which in this case is, I'm just putting this here. You can see we get a nice output that's completely different from the previous one. And then regarding this kind of layering concept of ggplot, we can go from our simple scatter plot here, and let's say we wanted to have a trend line, a regression line. Adding that is really easy. We just do again plus, since it's an additional layer. We use this function called geom_smooth. And a lot of these functions, all of these functions are really nicely described in the documentation. So if you're ever unsure about what specific geom to use for what, documentation's your friend, and also Google. And then I put this geom_smooth has this additional parameter here called method, because the default trend line for geom_smooth is a Loess curve, but I want a linear regression line, and I get a nice linear regression line. All right, one thing worth mentioning is I put in this AES mapping function, including the variables in both geom_point and geom_smooth. You can appreciate that as I add more and more layers, this can get unnecessarily repetitive. So what you can do is you can actually just take one of these AES with the variables and just copy paste it into ggplot, the ggplot function. And the subsequent geoms will just inherit this information from ggplot. So this second part looks a lot cleaner than this part. And then just to quickly re-emphasize this layering concept, when you just type in ggplot with nothing in it, this is what you get in R. You get literally a blank canvas. You add your data frame, you still just get a blank canvas because R doesn't know what to do with this data frame. When you add the variables you want to plot, R at least now knows, okay, so by default, this will be your x-axis variable and this will be your y-axis variable, so it plots the axes. But it still doesn't know what kind of plot you want. And that's where the geom function comes in. So in this case, it's a scatter plot. And then I add a smooth trend line, and I specify that I want it to be linear. And then it's hard to see here, but this linear regression line has error bars or like a shaded error area. And if I want to remove that, I can just set SE equals false. Right. So that was all a lot of talking. If you could make an equivalent plot using I believe the proteins package. So it's hard, again, it's hard to see this. So the goal is to try to reproduce this, even though it's kind of difficult to see it. But if you go back to RStudio and you scroll down, if we go to this line 40, exploring the proteins data frame, let's together work through. So these are the steps laid out to eventually produce, that will lead us to producing the plot that you see here. All right, so the first question is how many rows and columns does, all right, this is just a standard first question. It's not even particularly relevant to this task, but let's do it anyway. And as Paul pointed out last time, if you just run this line, it looks like nothing's happened because you have to go all the way to the end of this chunk to see the output. It won't appear in your console. So the dim function just gives you the number of rows and columns. There's a more powerful function from the tidyverse package called glimpse. And it also tells you how many rows and columns you have, but it also, in addition to that, it shows you what variables you have, what their data type is. So these are all character variables. So double just means a number with a decimal point in it in R. And then it shows you the first few entries for each of these. All right, so the goal is to create a new data frame that only contains the following 3 columns. So if you could just take like a little bit of time, maybe a minute to do this, and you can do this in any way you want. And then if after a minute someone is willing to shout out an answer, that would be great. Since we're using ggplot, I'm going to go the tidyverse way, but as long as your output is a data frame, you can use whatever method you want. All right, I'm going to guess everyone's got this because we are selecting columns. We select these 3 columns, uniprot ID, length, and mass. And you could just as easily do all of these lines, without creating any intermediate data frames, because you can do all your data wrangling using these tidyverse these dplyr functions, and then the output of that wrangling, you can just pipe that output into ggplot. I can show you what that means later on, but it's still useful, at least initially, or to maybe make these intermediate data frames. And even just in general, sometimes when you have like, I don't know, 100 lines of code, it's a little bit difficult to see what's going on. But if every so often you make a meaningful or sensible intermediate data frame, then that could be useful. I should also say that this little challenge here to select these variables is not necessary for making the plot, but I just put it in there just as an additional exercise.
Actually, why
Yeah.
try to do with a pipe instead of just you select that
Just habit.
have to pick one.
Yes. Yeah. But that's a good point. There's no in this, especially in this simple case, it's probably easier to not use the pipe, but habit. All right, from this data frame, and when I say this, I mean the one that I just made, proteins underscore small, only choose proteins that have a higher than average length. So I guess we make another intermediate data frame. And in this case, I'm going to play with fire and just call this second intermediate frame the same thing I called the previous intermediate one, acknowledging that I'm overwriting the previous intermediate data frame. This might or might not be best practice, but for this class, it's a simple example, so I'm just going to go ahead and do that. And so when I say choose So what function would I use for this task? Yeah. So as you know, within filter, you put in some kind of logical statement. And if that statement evaluates for all rows that evaluate, what's the correct phrasing? You put in a logical statement, and if it evaluates to true for a given row, we keep that row. And if it evaluates to false, we discard that row. So what we saw last week was some simple examples of, does it equal a certain number or does it equal a certain word? In this case, we want the length of the proteins to be higher than average. So we can kind of do this on the fly. One way to achieve this task is to beforehand work out what the mean protein length is by doing something like this. So we use the built-in mean function, and then we select length, and we go all the way down. We see that it's around 557. But again, and we'd have to assign, so we could just do this, for example, length greater than 557, and that would work. This is slightly, it's not a very clean way of doing it. You could just simply put in mean length, and that would work just as well. And this is more stable because if your data frame changes, but you still have a variable called length, this will still give you the right answer. But if you hard code it and put it in 577 or whatever it is, this is much more error prone. So we can just go ahead and do this. And so now we have the data frame in the right form. And the next prompt is to use the data frame above to make a scatter plot of length versus mass. So if you have forgotten what the code looks like, it looks like this. So all you have to do is use this code here, and you just replace the data frame and the variables. And if you like, especially if you're not particularly familiar with ggplot, you can do this kind of thing. You do data equals, and you put in your data frame name, oops, and you do mapping equals, whatever goes in there. And then to add the layer, you do plus geom underscore whatever the appropriate geom is for a scatter plot. And this template is one that is used, this kind of ggplot logic is used for whatever plot you want, however complicated.
Actually, when you make a return and go to the line below,
Yeah,
is it arbitrary how far you tap in?
unfortunately it is. As far as I know, R is not demanding, which is why you can get inconsistent. It's very easy to get inconsistent looking code. But on the other hand, it's not demanding, so that's a good thing. There are style guides, and actually Google has a style guide for R, which is probably best to follow. All right, so I'm going to go ahead and assume that everyone has the plot. You select the right data frame, and then we do length, comma, mass, and choose the right thing. And it says there's an X on line 60. What am I missing? I've done something wrong.
X equals length?
Let's see. Still there. And unfortunately, R isn't super clever. So when it says unexpected token comma, that's not really helping me. At least it's not helping me. No, like diagnose this problem.
Doesn't like the comma.
Well, if I don't put the comma, then I have to separate these. I could be complete, like you said, y equals. I could also specify, sorry, x equals. I could also specify y equals. It's not liking this. Something is missing.
Aesthetic.
Correct. So if I don't specify, if I don't use this aesthetic function, ggplot doesn't know how to map these points, these data points, or the data onto these points. Okay, so that was just the boring, basic scatter plot. I said next is clean up and add labels. Okay, so this is something that I haven't covered in the slides. But the point of this exercise here is to show you this kind of iterative layer by layer way of making a plot. So you kind of do more than 50% of, well, way more than 50% of what you need to make your plot. This is already a nice, informative scatter plot. But the labels aren't so great. Like the x-axis is lowercase l, lowercase m. So if you wanted to clean up stuff, you can use this labs function. And then you can specify x equals capital L length, y equals capital M mass. You can give a title. You can give a subtitle. And there are a few other options, but one nice one is to have a caption. And there you can put in your data source. Something like this. We run that, we get this nice output. Okay, and one unfortunate thing about the default look of ggplot is this ugly gray background. And I believe that's intentional, just to get you to put in the effort to improve the look. Now, one way to do it, one involved way is to use this theme function, which is it offers you full control over the look of your plot, but there's a lot to learn with this theme function. Instead, what you can do is you can use one of these built-in theme functions also, like theme underscore functions, that would just by running them, they change multiple aspects of your plot's look. So BW is a nice one if you want to get a nice clean plot. So you can see this is the plot we've made, a kind of basic plot. If we just add the BW, it just looks a little nicer. And then there are various other, like we can see here, it'll shows us the different choices. As you can see, there are many choices. We can try, like, for example, theme minimal and see what we get. We see how we like quickly change the look of our plot to look nicer. There are various packages that also have their own theme, and you could actually make your own similar functions. But there are various packages that already have these functions. I think there's one that has a package for to get all your plots to look like plots in nature, just by adding. It's like theme underscore npg or something. All right, so that's pretty much it for the basics of ggplot. I'm not going to say this. Apparently, it means with a little help from my friends. And the reason for that is there's this really nice package called Esquisse. And we will explore it today. So I'm assuming you don't have this package. And if you don't, this is how you install. So this package is on CRAN. And the install underscore packages Esquisse, or whatever the name of the packages you want to install is what you run if you want to install something from CRAN. Let's say you don't want to go to the trouble of typing it out. You can install something from from within our studio itself. If you go to Tools and click on Install Packages, you see here you can install from CRAN and and then you just type in the name of the package. If it does exist in CRAN, what you'll see is it'll find it. And then you can just click install. That's if you don't want to run the code. And also this offers you other choices, but it's probably just best to leave it as the default. So I'm going to give it like a second or so for you to run that, to install it. And once you've installed it, I give it like a few seconds.
And if you're installing, you just type out install parentheses.
You would do I don't have the line up here, but let me type it here in the console. You would do install dot packages, and then you must remember to put the name of the package in inverted commas. Otherwise, it won't find it. No, you don't need to do that. All right, so let's assume you have it. And if you do, there's this, as is the case with lots of packages, this package also has a bunch of useful functions. One really useful one is, maybe this might be the only one that's relevant to us, is this esquisse function. So just like we use launch underscore projects from the CBRG package, we could type this out. So one thing worth pointing out is, why am I doing this esquisse : ? You could also do this, for example, when you use your select function from the deployer package. You could do it. You could either do library deployer, load your package, and then you do, I don't know, select something. What you could also do is you can just skip this library step and do the name of the package and then do : telling R that I want to select this function from this package. This is actually, so it's obviously more verbose, but it's more robust because unfortunately, select is a very common word. So the select function, or different functions named select, exist in different packages. And if you are ever unfortunate enough to have those two packages installed in running in R at the same time, there'll be a conflict. So in those cases, you would have to, this is one way to specify that, no, in this case, I want the select function from the deployer package, and maybe a few lines later, I want the select function from another package. So this is just a more robust way of writing your code. And in fact, we could do, if we wanted to be really pedantic, this would then become ggplot2, and this would become ggplot2. But no one ever writes code like this. That's too much. Okay, so back to this esquisse function from the esquisse package. You just run it like this, and you give it the name of a data frame that exists in your environment. So we know proteins exists. So does Golub subjects. So does protein small. So let's try proteins. And if we just run this, we get this this little app. And you can see that it's already provided us with the names of all the variables that are in our data frame. And it has these little boxes here that correspond to different elements, different parameters in ggplot. So there's the x-axis variable, y-axis variable, and these other parameters that I haven't covered. But they, as you can tell, you can map a variable to a color component of your plot using the color parameter and so on. So let's keep it simple. Let's try to do what we did previously. We can take our length, and it's really clever because if you just specify the x variable, sorry. Huh. I don't know why I can't increase the size of this. That's unfortunate. Can you see this on your screens? Like, do you have Esquisse running? All right, so for whatever reason, I can't adjust the size. Hopefully, this is horrible, but hopefully you can see that if I just put in length, it's already worked out that, well, there's not much I can do with just one variable. Histogram's probably what you want. So it plots a little histogram for you. And if you click on this, you can see the other, gosh, you should see other plot types available to you. And if you just click on the type, it'll give you the resulting plot. Now, if we wanted to make what we have made, our little scatter plot, length against mass, it already works out that you probably want a scatter plot, which is, can't really see it, but it's there. And then if you click on this, it'll show you all the other various plotting options. We go back to this. So that's great. So we can just do this like drag and drop thing to see what we want. So that's kind of useful. And then you can also like specify the title, like length, mass. And if you make these changes here, these changes will be reflected. Oops. You can change font and so on. These changes will be reflected on the plot you see here. So this is a nice like GUI tool that you can use to make a plot using ggplot without actually running any code. And maybe the most important thing about this is if you click on this code button here, all these changes that you've made by dragging and dropping and selecting different things, it's kept a track of it and the code. So like sometimes you want, for example, a particular color, and for that you would need to know the hex code. So by doing this like point and click business, it's already worked out everything for you. And so then you can just copy paste this, close this into your R session. So let's say here, you run this, you get this. This is a really useful tool for kind of playing around with ggplot. That's particularly useful when you have first encountered ggplot. So I have this little exercise here. It says, so use this tool, like play around, like try to explore the different variables in the proteins data frame. And if you don't like the proteins data frame, you can use whatever you want. You can use these three data frames that are already available, or you can import something that you like, and you can just play around with. Maybe you've done an experiment and you import that as a data frame, and you can explore that quickly using Esquisse, and then you have the code for it. And once you have a plot that you really like, copy paste that code into your chunk and just go through it line by line, especially if this is a plot that's kind of sophisticated and you don't really know what every line is doing. Try to do that here. Like that's your opportunity to go through it line by line and see what's going on. One really useful thing to see how things work is to just comment. Like for example, this one, if I didn't know what theme minimal did, you can just comment it out. So the way to quickly comment is to go Command-Shift-C. And now if I run this, I see that I still get a scatter plot, but oh, okay, so this is what theme underscore BW minimal does. It gets rid of this gray background. Yeah, that's pretty much it for today. One really useful resource, there are lots of really great resources for ggplot in particular, but one really useful one is this R graph gallery. And it has examples of pretty much every kind of plot type you would want to make. And if you click on, for example, violin plots here, it'll show you, or violin charts, it'll show you different examples that you can further click on. And just like with Esquisse, not only does it show you these examples, it shows you the code goes along with them. So this is a very useful tool. It also has, I believe, somewhere a flow chart. Like if you have two numeric variables and one categorical variable, what are your plotting options? So you can use that kind of decision tree to maybe even discover plot types that you weren't previously aware of. And with that, that's it for today. Just as a reminder, if you want to save all of this, remember to do save as so that it actually saves here. I'm actually curious. Okay, yeah. Yeah, once you do save as and you make sure that it's here, then you just have to hit save, and obviously it'll save to this and not the other directory. So there are no, so the next thing to do, just to kind of reinforce these concepts or to at least practice them, you can run the launch_exercise, launch_exercise. I'll get there. And then 2, and this is the exercise for today's class, or today's meetup. And there are just 5 questions. So some of these are a little bit more, I guess, challenging, and some of you'll have to use concepts that haven't actually been covered. But this is your opportunity to look up these functions and what they do. Remember, to look up a function, you just do question mark and then the function name in the console, or you can just Google it. And if you do get stuck, you can do launch_exercise and then show answers equal to true. And that's only if you really get stuck or you want to compare your answers with, not the right answers, but my answers. All right, 11:54. Any questions? If there are no questions, thanks for coming. Next week onwards, next week we begin the actual computational biology component of this meeting group, this meetup. And we'll begin with linear models and RNA-seq analysis. But yeah, thank you.